Welcome to the course titled Descriptive Statistics. All right, um, what is statistics? Statistics is the science of the collection, organization, analysis of data, and interpretation of results. So, um, there are two main branches of statistics. The first one is descriptive statistics, and this is the branch of statistics that deals with the summary of data. You summarize data in order to obtain useful information. So then the second branch is called inferential statistics. Inferential statistics is the branch of statistics that is concerned with making logical conclusions that are statistically valid about the population on the basis of a sample selected from the population. And that is what we refer to as hypothesis testing. So we take a sample and then we try to find out if a claim about a parameter is true or not. All right, so going on, what is a variable? A variable is a characteristic that can assume at least two values. So it can assume two values or even more. All right, and going on, there are a number of some type of variables that we may have. All right, the first one is the quantitative variable. A quantitative variable is a variable that assumes numerical values. All right, so for example, your weight, temperature, height, and many more. The qualitative variable or a qualitative variable is a variable that assumes non-numerical values. Examples include your gender, income, name of persons, name of countries, and so on. Now, the discrete variable, a discrete variable is a variable that can assume values from the set of non-negative integers. That is, you can take values from 0 to infinity. So 0, it can be 1, it may be 2, it may be 3, and it may be, but it can be something like 2.1, 1.2, or some, no. Just, it can be integers, but non-negative integers. Okay, so the last one we're looking at is the continuous variable. A continuous variable is one that can assume values from the set of real numbers. And what do we mean by the set of real numbers? We are talking about an interval. It can take values like not just the 0, 1, 2, 3, and so on that we have here, but it can take values like 0.1, can take values like 1.2, can take values like 1.3, and in some cases it may even take negative values. So you may have something like minus 1.3, it may be minus 2, and like that. So it can take values from minus infinity, to plus infinity. So any number at all. All right. So that is the continuous variable. And going on, what is data in statistics? That's what I refer to as statistical data. Data is the collection of raw facts, and the singular of data is datum. Okay. All right, and types of statistical data with respect to values. Number one, we can have the categorical data, and this has to do with numerical values. Okay, so that means your data set has variables that can assume non-numerical values. All right, and we have numerical data. It means this data has variables that can assume numbers. So, all right, that means you don't have categories here. And sometimes your data may be made up of both categorical data and categorical variables and numerical variables, which means you have a mixture of the two. So your data is both some partly categorical, partly numerical. All right, types of statistical data with respect to source. primary data. This kind of data is data that has just been collected by the researcher for a particular purpose. So it had not been collected before by anybody, but there's a researcher who wants to do something and collects it for his own purpose. All right, secondary data. This type of data is data that is obtained and used again. So it had been collected by somebody before, but after the person has used it for his own purpose, somebody else is now obtaining it and using it for another purpose. So that's secondary data. All right, so methods of data collection. Number one, the use of mailed questionnaires. You mail the questionnaires to the respondents. Direct administration of questionnaires. This one, you hand over the questionnaire to the respondent and wait for him to fill it and return it to you. Then there's business activity records. For instance, you may have maybe the payroll. You may have something like maybe okay, what are we doing in the place of work? Record that. So your minutes of meeting and the others. Official records. So in an official environment, you may have records that can help you when you need data. All right, statistical surveys. Somebody may go on and say, okay, we are going to learn about this, we are going to get this, we are going to get that. All right, so census, you may count the number of people or things in the particular area, the total, everything in the population or everyone in the population may be actually taken into consideration in your study. That means you have a census. But if you just take a part of the population, not the whole population, then you have your sampling. So planned experiments. So sometimes you may control the environment or control a particular system in order to have some results. Then it means you are okay. In order to see how your result will be affected, it means you have a planned experiment. All right. Scales of measurement. Now the scale of measurement okay, we have 4 levels of measurement, or you may say scale of measurement. The first one is the nominal scale. This one has to do with names. For instance, gender, male and female. Okay, it has to do with names, but no order. So you can't say male is greater than female or female is greater than male. So fruits, for instance, apple, mango, and orange, you can't say any one of them is greater than the other. So human names like Elvis, Kelvin, Craig, Suleiman, Chidinma, Bolaji, you can't say any one of them is greater than the other. All right, and you cannot do any mathematical operation like addition, subtraction, multiplication, division, and the others, square roots, and many others. You can't do them on the variables that follow the nominal scale. All right, so you can't do them on variables that are on the nominal scale. The only statistical measure that can be obtained using the nominal scale is the mode. For example, if you are given the data on fruits, apple, mango, orange, mango, apple, orange, apple, apple, then the mode is going to be apple. Looking at it, the apple appears more time than any other thing. So the mode will be apple. All right. Now, going on, the second level of measurement that we can have is the ordinal scale. This scale of measurement has to do with ordered names. So it has to do with names too, but in this case, order is part of it. Now, for instance, income level, you have low, middle, and high. Yes, the low is less than the middle is less than the high. All right, university degree, you have first class, second class upper, second class lower, third class, and then pass. So no mathematical operations can be done when using this scale, except for the fact that you can say one level is greater than the other. Okay, so you can't do any mathematical operation, but you can obtain 2 statistical measures on the mode. The first one, 2 statistical measures on this scale. You can obtain 2 statistical measures, and the first one is the mean, and the second one is the mode. For example, if you're given the university degrees maybe to be first class, second class lower, second class upper, second class lower, first class, third class pass, first class and pass. Then the mode will be first class because it appears much more than any other one of the classes. All right, and after rearranging in ascending order to give this, you're going to have 2 to be in the middle. So looking at this now, 1, 2, 3, 4, the first 4, and then the second 4, 1, 2, 3, 4, and 2 is in the middle. So you're going to have 2, all right, as the median. Now the interval scale has all the properties of the ordinal scale, but it also allows for the use of numbers. So this time around, on which these numbers are numbers on which mathematical operations can be done. So, however, it has no true zero. So it has what we can refer to as, it has a structural zero. What we can refer to as structural zero. So it doesn't have a true zero, but it has what we can refer to as structural zero. All right. Now, we can obtain the mean, variance, and standard deviation when we're using this scale. So the statistical measure we can obtain include the mean, median, the variance, coefficient of variation, and many other statistical measures. So example of your variables that are on the interval scale or are measured on the interval scale are temperature, exam scores, age measured strictly in minutes or higher units. So it means if you forget about seconds and so, okay, just minutes. For instance, a child who is born and it's not yet 1 minute since the child was born, then you will say the child's age is 0. Nonetheless, the child's age is counting, but because we are not considering the seconds, we are going to say the child is 0 years old. All right, going on. Okay, the ratio scale. The ratio scale of measurement has all the property of the interval scale, but it also has true zero. It has a true zero. It doesn't have a structural zero. Now, the statistical measures that can be used include the mean, median, mode, variances. You can have the variance, standard deviation, coefficient of variation, and many more. Examples include the weight, height, acceleration, age measured strictly. This time around, strictly in seconds. Okay, not strictly again. Age measured without restriction in the unit. So let's assume we want to use hours. It means that when it's just 2 seconds, we are going to have, if we have maybe 2 hours and maybe we're measuring in hours now, 2 hours and then maybe plus some minutes, then you can have that as a fraction. Maybe you may have 2.02 or 2.1 or 2.3 hours. So if you're measuring in years and it's not yet exactly 1 year, after maybe a few years, for instance, you may have 2 years and maybe 6 months, you can have that in fraction. So there is no restriction on the unit in this case. Age measured without restriction on the unit. Okay, so you may be measuring in hours, but you still take into consideration the minutes and seconds, or you're measuring in years, but you still take into consideration months, minutes and seconds, and so on. All right, so that's that about that. Now we go to sampling. Now, but before we do the sampling thing, let's look at two things. Population and sample. Population is the collection of all elements of study which have the characteristic or characteristics of interest. Now, I want you to be aware of this, that what we refer to as element can actually take a number of, can be called a number of names. So you may refer to the units in your population, what the inclusions, you may refer to them as objects. So you may refer to them as elements. You may refer to them as units. Okay, and sometimes you may even refer to them as subjects, depending on how, depending on when you may refer to them as subjects when it is appropriate. Now, all of these. So, what are the objects? They may be human beings. So, your population may consist of human beings. Human beings. They may be things. I mean, it may be even inanimate objects, and they may be living things. So, they may be animals. They may be plants. So it depends on what you are studying. So you may refer to them as objects, elements, units, or subjects where it is appropriate. All right, so going on, a population is the collection of all elements of study which have the characteristics of interest. Then sample. Sample is a subset of the population which is selected by some sampling method. Then, so that means you have a big population, maybe of 200 people, but this time around you feel like you want to select just maybe 35 of them for use. So if you select, it's more or less like you have something like this and you're like, okay, no, I don't want the whole thing. Let me just take a few. So you decide to take maybe just something like this, or you come here and say, okay, let's select just this part. So 35 out of the 200 you have is actually a subset of the population. So you may take 35 units instead of the 200 units, which I've also referred to as elements. So that means you're taking just a sample from the population. Now, parameter. A parameter is a numerical measure of a characteristic of a population. What do I mean by that? You may have, okay, some examples of the parameters are things like your mean, which I will refer to as mu, mean, the variance, which I refer to as sigma square. You may have also your population total, which I will refer to as capital Y, and you may have your coefficient of variation, let me call that CV. So the mean here, variance, okay, so population total, the Y there, population total, so I just call that total for now. I'll just call that total for now. And you may have your coefficient of variation. So coefficient of variation, all of these, when you obtain them, they are just some parameters that you can get for your population. So using all the population values, you can have a numerical measure for a characteristic in the population. And but sometimes you may not have it for the whole population. So you may obtain it for just a sample. That means using some units that you have selected, a subset of the population. And that will mean that you have an estimate. So when you have an estimate, we refer to them as a numerical measure. Okay, we refer to them to an estimate. Okay, we refer to an estimate as a numerical measure of population characteristic. So with respect to a parameter, what are the parameters? Like what we have here, the variance, the mean, the population total, and the coefficient of variation. So, and this time around, we may refer to the mean. An estimate for the mean will be referred to as X bar. So this is an estimate of the mean. The variance will be referred to as S. The population total will be referred to as, let's take note of this, Y hat, and then coefficient of variation may also be referred to as CB hat. All right, so that way you have an estimate. So the reason why you call this an estimate is because you are taking a subset of the population. So instead of the whole 200, you may take 35 and then calculate these things that I have here. And when you do that, that means you have estimates. So if you do for the mean, then you have an estimate for the mean. If you do for S, you have an estimate for the variance, you have an estimate for the variance. If you do for Y hat here, you are estimating for Y here, but the value you obtain for the sample will be Y hat. Then it means the parameter you've estimated is Y hat, and that's an estimate. CV hat is an estimate for this parameter, CB. That's why I have a definition to be an estimate is a numerical measure of the characteristic of a sample with respect to a parameter. So you are obtaining that estimate for a parameter. That's why you call it an estimate. So we don't know the true thing, but we have something close to the true value. And these are the true values, but these are the estimates. All right, so statistics. Permit me, it's not statistics, statistic. Statistic is a numerical measure of the characteristic of a sample without respect to any parameter. So when you don't really have in mind that you are estimating a parameter, but you just want to obtain, that means you just get a sample and you just obtain maybe your X bar, S, and the others, but you are not really looking at estimating a parameter, then it means that you don't have an estimate, you have just a statistic. So in that case, all statistics, and I'm talking about statistic now as in what you have here, but the plural of it will be statistics. All estimates rather are statistics, but not all statistics are estimates. So note something, statistic and statistics are two different things. So the plural that I called statistics here actually refers to this statistic, the plural for this statistic here. Okay, so don't confuse the fact that I pluralized it here. The singular means statistic. That's what I was talking about. But statistics, as it were, in capital letter, I have to change this. This is capital letter. So supposing I didn't put this first, this would have been small letter. So statistic here is referring to what you have here. Statistic is referring to what you have here. And that one is a numerical measure of the characteristic of a sample without respect to any parameter. Whereas statistics, as you have it here, this one is the science of data collection, organization, processing, analysis, and interpretation of results. So this one is always having a capital letter, but this one is not always having a capital. In fact, doesn't have a capital letter when it comes in between. Maybe when it comes in between in a sentence, but if it starts, it can have a capital letter. Like for instance, when it started here. So when it is pluralized to statistics, it still does not mean the same thing as the statistics that start with capital letter. So statistics, it still does not mean the same thing with this one. This one is the science of the study. So even if this one, the second one that I've written, comes in between in a sentence, for instance, it comes in between, it will have to have a capital letter. And you can see that here now already. But when this one comes in between in a sentence, it didn't come in between here the other time, whether as in plural form or singular form, then it still means what you are seeing here. Okay, so please take note. Statistics as a science And a field of study will always have capital letter. All right, so please take note of that. And finally, we go to sampling. Now, what is sampling? Sampling techniques. You are taking a sample, you are taking a subset of the population for your study rather than the whole population. That will save your time. All right, so if you are doing that, because you may not be able to access every unit in the population, if you're doing that, then one of the techniques you can use is what we call random sampling. And what does random sampling involve? Random sampling says, okay, use a randomization mechanism, a randomization technique to select the units to be included in your population. And when you are using this randomization mechanism, it will bring about equal chance of selection for all the units. For instance, okay, the randomization mechanism could be casting a lot. So it could be that you're casting a lot. It could be that you're using a hat method. It could be that you're using a random number table rather. It may be that you are using a computer program. All right. So if, for instance, we have units in our population, we have units 1, 2, through to 10, and the investigator uses a hat method. He may decide that, okay, I want to pick 4 units alone. So he using a hat method, he will write each of the units on a piece of paper and wrap them and put them in a hat and begin to shuffle. And then he may have somebody, or he himself may do it, to pick 4 different 4 papers from the hat. And it may be done at once or one at a time until he has 4 units. And when that is done, he may begin to open them. Now, so he may have any of the units and any 4 of the units. So that means that you are given equal chance of selection to all the 10 units, but you only pick 4. All right, so we go to the systematic sampling. The second one, called systematic sampling, says, okay, we are going to use the randomization technique, but we only use it to pick the first one. And when we have done that, we can now pick every kth element thereafter. For instance, maybe let's assume that our random start, let's assume that the investigator decides to pick 6 units, and but he decides that he will pick every 4th unit. That's the K is 4 here. Every 4th unit thereafter. So when he decides that, assuming that the one he picked by the first one, which is the only one that you pick randomly, let's assume that he picked that one and that one happens to be 2. Then he's going to pick every 4th element thereafter. So for instance now, if he picks 2 here, you count 1, 2, 3, 4, then he picks unit 6. So add 4 to 6, that should give us 10. Add 4 to 10, that should give us 14. Add 4 to 14, that should give us 18. Add 4 to 18, that should give us 22. So that means that a sample will be 2, 6, 10, 14, 18, 22, so, which you can see in red above. All right, so that means those are the units that he will be taking in a sample. Those are the units he will select. So your units, actually what you have done here is that you have labeled your units 1, 2, 3, 4 until you get to 10. The same thing has been done here. You have 22 units in your population here. You've labeled all the units, all the elements in the population. You've given them a number. You've assigned a number to them. That's what I mean. So here you have just 10 units in the population, while here you have 22 units. All right, so the next one is convenient sampling. Convenient sampling says, okay, no, you just select units that are easy for you to access. Don't select all the units, but the units that are easy for you to access, select them. All right, look at this now. For instance, the investigator may have 10 units in his population, and then he may look around and look at the units again, and then he finds out that units 4, 7, and 3 are accessible to him easily. They are very easy for him to access. Okay, easily accessible to the investigator. So he may decide to pick them. This method of sampling is not a very good one, In fact, you should avoid it. Why? Because it's prone to bias. In fact, it's biased already. It's just, let me say it this way properly. It's a biased kind of sampling method. It introduces bias to the what you are doing, and that's because the people that are easily accessible may not even have enough information for you. That means they may not, or they may have some kind of information that you or the information turnout may be poor. You may have information from them, but you may not touch the units sufficiently. Like, I mean, the population, you may not select units that are representative of the population enough. So that's one disadvantage of it, and it's probably the worst type of sampling scheme you may use. So avoid it. Let it be a last resort to you. If you have no other way of doing it, and then you may be thinking of convenient sampling, but it should never be the first to come to your mind. All right, so stratified sampling. This one says, okay, divide your population into two groups, which we call strata. Each of the group will be called a stratum. So when you look at the groups, all of them together, the groups, then you refer to them as strata. If not just one group, you refer to it as stratum. So stratum, strata. Now, you divide the population into strata, and then from each stratum, you now select a sample. You may select the sample using what we call the random sampling, or you may select using the systematic sampling. Now, for example, suppose an investigator wants to select a sample of 5 from the population of units, okay, shown below. Now, he divides the population into male and female, and selects 2 males and 3 females. Then the sampling unit will be 28156. So this is the population. Originally, population was unit 1 to 10 now. And when he divided the population to male and female, he found out that unit 4, 2, 8, 3, 10, and 9 are males, while unit 1, 5, 6, and 7 are females. So he selects just 2 male. He may use a random technique or systematic sampling technique. Then he has 3 females. Okay, so that's that about the stratified random sampling. Now the cluster random sampling is another sampling technique. But here, this one says the population is already existing in groups, which we refer to as clusters. And you just select a number of clusters, and then you study all the units that are in that cluster. So for instance, supposing we have 1, 2, 3, 4, 5, 6 clusters, and I select, maybe I'm the investigator now, I select only 2 of the clusters. Then I will check. In the first cluster, I can see that there are how many units? 1, 2, 3, 4, 5 units. So I'm going to study all 5 of them. The second cluster I've selected has 2 units, so I'm going to I'm going to study all 2 of them also. So whatever I'm taking from here, I'll take from all 5. Whatever I'm taking from here, I'll take from all 2. All right. If I select a cluster and it has just 1 unit, I will also study from that 1 unit. But in this case, our sampling, what we are going to be doing, we involve the units, all the units in cluster 1, and this is cluster 2, cluster 3, this is cluster 4, cluster 5, cluster 6. So I'm only going to be using all the units in cluster 1 as well as all the units in cluster 4. All right, so with that, we've come to the end of this lesson. Thank you.